Welcome back, viewers, to Learn with the Nexus. My name is ROHITHDASARI. Lab number is 23CA2505. First semester, Devo section. Course title is Mathematics. Course code is BMATS 101 from Sri Venkateswara College of Engineering. Yes, Gauss Jacobi iteration method.
Action.
What is Gauss Jacobi method? Jacobi method or Jacobian method is named after German mathematician Carl Gustav Jacobi Jacob in 1804 to 1851. The main idea behind this method is, let's say for a system of linear equation a11x1 plus a12x2, and it goes to till a1n xn, which is equal to b1, a21 x1 plus a22 x2 plus, and it go to a2n plus n, which is equal to b2, and as through the column an1 into x1 plus an2 x2 plus ann xn equal to bn.
Action.
Now we shall begin to solve equation 1 for x1, equation 2 for x2, and so on equation in for xn. We get x1 equal to 1 divided by a11 whole multiplied by b1 minus a12 x2 minus a13 x3 minus till a1nx n, and x2 equation equal to 1 divided by a22 whole multiplied by b2 minus a21 into x1 minus b23 into x3 until it goes to minus a2n into xn. Xn equal to 1 divided by ann whole multiplied by bn minus an1 x1 minus an3 into x3 minus ann minus 1 xn, at last is minus 1. By making an initial guess for the solution, x of 0 equal to x1 whole multiplied by 0 comma x2 whole multiplied by 0 till goes to xn multiplied by 0, and substituting these values only to the right hand side of the above equation, we get first approximation x of 1 is equal to x1 of 1 comma x2 of 1 till xn of 1. Continuing this process iteratively, we get sequence of approximation x of k such that k is a infinity. This sequence converges to exact solution of the system of equation up to a given error tolerance.
Action.
Let's see convergence of approximation. The sufficient condition for the approximation convergence of the obtained by Jacobi method is that the system of equation is diagonally dominant, that is the quotient matrix A is diagonally dominant. The matrix A is said to be diagonal dominant if A of II is greater than or equal to sigma of nx equal to 1, or Aij for I is not equal to j. That means the absolute value of a diagonal element is greater than or equal to the sum of all elements of the corresponding rows.
Action.
Let's try an example. Solve the system of equation using the Jacobi method. 26x1 plus 2x2 plus 2x3 equal to 12.6. 3x1 plus 27x2 plus x3 equal to minus 14.3. 2x1 plus 2x2 plus 17x3 equal to 6.0. These three equations can be obtained the result correct to the three decimal places. Solution is, first check for the convergence of the approximation. 26 is greater than 2 plus 2 and 27 is greater than 3 plus 1, and third equation 17 is greater than 2 plus 3.
Action.
Hence the given system of equation are strongly diagonally dominant, which ensures the convergence of approximation. Let us take the initial approximation x1 of 0 equal to 0, x2 of 0 equal to 0, and x3 equal to 0 of 0. First iteration is x1 of 1 equal to 1 divided by 26, 12.6 minus 2 into 0 minus 2 into 0. We get 0.48462. And we see, let's see, x2 1 equal to 1 divided by 27 whole multiplied by minus 14.3 minus 3 into 0 minus 1 into 0, which we get minus 0.52963. For x3 equal to 1 divided by 17 whole multiplied by 6 minus 2 into 0 minus 3 into 0, we get the answer as 0.35294.
Action.
Second iteration, x1, let's put value 2 equal to 1 divided by 26, 12 into 6 minus 2 into minus 0.52963 plus 0.35294 whole multiplied equal to 0.49821. And for x2 we put the value 2 equal to 1 divided by 27 whole multiplied by minus 14.3 minus 3 into 0.48462 minus 1 into 0.35294, which will giving us minus 0.59655. For x3 we put value 2 equal to 1 divided by 17 whole multiplied by 6 minus 2 into 0.48462 minus 3 into minus 0.52963, we get the answer as 0.38939. Likewise, there will be modification in approximation with each iteration.
Action.
Let's see in a table form. Let's take a kth iteration 0, 1, 2, 3, 4, 5 till 5 iteration. Let's see x1 value. We initially put 0, after we'll get 0.48462, and second iteration we get 0.49821, and third iteration 0.5006, and fourth iteration we will get 0.5000, and fifth iteration we get 0.50001. For x2 initially we put 0, in first iteration we get minus 0.52963, and second iteration we get minus 0.59655, in third iteration 0.59941, and fourth iteration minus 0.5999, and at fifth iteration we get minus 0.6000.